Okay, so we have another question. Okay, after reading the problem, the first thing to notice is that these two are very similar. So you can take f of both sides. I won't draw the other side. And then you will get f of left-hand side, which is this random, stupid, expression. And then you take that and you use the equation first time, you get f of the right hand side, you use it a second time, you will get the inside itself, which is quite convenient. Now, next thing you should notice is that since we have this and 2015 is odd, we can get the bijectiveness. Now, with the bijectiveness, we can go here and safely assume that f of x is equal to x. Now, that's something really important. We can just go and change y to f of y. So, y to f of y. Because this will allow us to change the left-hand side to f of x to 2015. Y to 2015, which is pretty simple. And the right-hand side is actually just f of x to the 2015 and f of y to the 2015. You can now substitute in y equals 0, which is quite a natural thought. Let's say f of 0 to the 2015 is, let's say, b. So then f of x to the 2015 is just f of x to 2015. And actually, I'll write it this way, plus b. Okay, so now that we have this, we can substitute here. And that will give us f. Let me just copy this thingy down here. I missed the open bracket. And then on the right side, you can just make it fx to the 201 plus y to the 201. Oh, my bad. Plus f of y to the 2015, and then minus 2b. So now you immediately recognize this as a standard Cauchy equation. It's just f of x equals x minus 2b. Now you have to substitute this in somewhere, so let's substitute it in here, because that's the only place where b appears, and we want to prove that b equals 0. Did I not mention that? Oh, okay. So after substituting in, remember that this is only for x's in the rationals. After substituting in, I'll remove the substituting process. But let me just tell you that it's a equals positive minus 1, b is 0. Now with that, it's much better because since b is 0, we can just change that up and safely say that, not deleting, and safely say that this holds. Now, it's obvious that a's positive / negative won't change anything, so let's just assume a equals 1. So now f of x is x. Done? No, because it's real numbers, so for x, it's in rational. So we have to remember that. Okay, now what do we do? Well, so we already have its additiveness. I don't know how to pronounce that word. Additiveness. So we can just let's say we pull this thingy out. Since b is 0, I won't pull it out as well. Hold on. This lasso is giving me lots of trouble. Let me lasso it properly. Okay. So we can just take x, change x to 2015 and y to 2015 to just x and y. That would make things much more simpler. And that would mean we have additiveness. So let me just delete all those 2015s here. That just feels great, you know what I mean. Deleting all the 2015s. I'll just rewrite it. So now what do we do? Well, we have 1, 2, and 3, I guess. 3 equations. And now the next thing to notice is that if Q is a rational, well, if Q is a rational, we can see that f of x plus q is just f of x plus q, and if f of x q, it'll just become f of x times q. Not xy, my bad. X q. Good. So now what? Now what do we do? Well, hey, this, you should know that if f is a polynomial, it's given that f is a polynomial, this will mean f is a perfect power. So maybe this will be useful. Well, indeed, this is useful if you make x become x plus q. Okay, you'll actually find that, so let's calculate. The left-hand side is just f of, oh no, things are about to get messy. So you will find that f of, okay, let's do the right-hand side first. Is f of x plus q to the 2015. That's also quite messy. Let's just actually put it right there. Well, then you look at the left-hand side and you find out that it's actually just f of x plus q to the 215. Okay, so we have these two are equal. How do we utilize that? Well, actually, let's change this up a bit. It's actually q to the 2015 plus 2015 q to the 2014 f of x plus dot 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 plus, you know what I mean. And then for this one, well, if you actually took the time to expand it out, you'll see that it's actually quite similar. But if you compare the differences, it's where it's in the second last term. And I won't do the exact expansions, but you'll get f of x squared equals f squared of x. And now this is larger than, I'll make this clearer, I guess. So next, this is larger than or equal to 0, and we have that it's at least 0, which means it has about. Therefore, we can change the Cauchy equation to all real numbers, and we're done. So f of x is just, let's pull out our answer here. F of x is just x, and we are finally done with our proof. I hate outliers. It seems like we assumed a equals 1. But what if a is equal to -1? Hey, we didn't think about that. That means it's actually negative x this time. So f of x equals negative x should also be a solution. Oh, we made a mistake here. It should be f of x equals plus minus x. And this time we are actually done.